Imagine an enemy launches a missile that costs hundreds of thousands, or even millions of dollars. You have seconds to decide what to do, and the weapon you fire to stop it may cost millions more. Now America is trying to change that equation. On-screen text, the cost war. But the real secret isn't the missile, it's what's inside the rocket motor. The headline sounds incredible, a $10 million missile interceptor. But that's not actually what the number means. The U.S. Missile Defense Agency awarded XBOW Systems a contract worth roughly $10.98 million to develop and flight test a low-cost interceptor. The real goal is much more ambitious. An interceptor with a target unit cost below $750,000. And that price target could be more important than the missile's speed. Modern missile defense isn't simply a battle between missiles. It's a battle of economics. If an attacker can launch threats faster and cheaper than a defender can replace its interceptors, even an extremely sophisticated defense can face a dangerous problem. The question becomes simple. Can you afford to keep shooting? And this is where the economics of missile defense become frightening. This is where XBOW Systems enters the story. The New Mexico-based company has built its reputation around solid rocket motors and advanced manufacturing. Now it's taking that technology into a much bigger challenge, building an affordable interceptor for America's future missile defense architecture. But making an interceptor cheap creates another engineering problem. At the heart of a missile interceptor is propulsion. The rocket motor has to generate enormous acceleration in an extremely short period of time. But propulsion isn't just about producing thrust. It has to be reliable, manufacturable, lightweight, and affordable. And that combination is much harder than it sounds. A solid rocket motor contains its propellant in a solid form. Once ignited, combustion produces extremely hot gases. Those gases expand and accelerate through the nozzle, producing thrust. For an interceptor, that thrust has to arrive at exactly the right moment and remain predictable enough for the guidance system to do its job. But here's where this program gets interesting. XBOW isn't only trying to make the interceptor cheaper, it's trying to rethink how the propulsion is manufactured. XBOW has emphasized additive manufacturing as a way to accelerate the development and production of solid rocket motors. Instead of relying entirely on traditional manufacturing methods, components can be produced using digitally controlled processes. The potential advantage is speed, flexibility, and the ability to iterate designs faster. But a cheap rocket motor doesn't automatically create a cheap missile interceptor. The interceptor still needs sensors, guidance electronics, control systems, and a way to reach the target at precisely the right moment. The basic chain is simple to understand. Detect, track, calculate, guide, intercept. Missile interception is essentially an extremely high-speed, three-dimensional chase. The defender isn't simply aiming at where the target is. The system has to predict where the target will be and guide the interceptor toward an interception point. And the faster and more maneuverable the threat becomes, the harder the problem gets. Now introduce a hypersonic weapon. We're talking about an object traveling at more than 5 times the speed of sound. Some advanced threats can also maneuver, complicating the defender's prediction problem. This is why developing a low-cost interceptor isn't simply about making something cheap. It has to be capable enough to matter. And that brings us to the real question. What exactly is this new interceptor expected to defeat? And hypersonic weapons make the problem even harder. Modern air and missile defense has to contend with different types of threats. Ballistic missiles follow one class of flight profile. Cruise missiles operate differently. And emerging hypersonic systems create another level of difficulty. The low-cost interceptor program is therefore part of a much larger effort to create more scalable defenses. And there's another lesson changing modern air defense: drones. The battlefield has demonstrated what happens when inexpensive weapons can be produced and launched at scale. That creates pressure for defenders to find cheaper ways to defeat them. XBOW has separately developed Buckler, a lower-cost interceptor aimed at certain drone threats. The idea is straightforward. Don't use $1 million solution when a much cheaper one can do the job. Now imagine facing not one incoming missile, but dozens. But producing an advanced interceptor isn't enough. You need the industrial capacity to build thousands of them. That means factories, rocket motors, materials, electronics, testing facilities, and a supply chain capable of operating at scale. The next missile defense race could therefore be fought as much inside factories as on the battlefield. America's missile defense industry already includes enormous defense contractors and established propulsion suppliers. But the low-cost interceptor effort is also opening the door for newer companies to challenge traditional production models. The objective isn't necessarily to replace every existing interceptor. It's to add another layer, one designed around affordability and scale. Now comes the difficult part. Can an interceptor actually reach that cost target while maintaining the performance and reliability required for missile defense? That's what testing will ultimately determine. A contract is not a deployed weapon. A prototype is not a proven defense system. And a cost target is not the same thing as a final production price. This section is very important for war tech credibility. But there's another threat changing the economics of air defense: drones. Because the ultimate challenge isn't stopping one missile. It's defending against the possibility of many threats arriving at once. That changes the definition of a successful interceptor. The winning system may not be the one with the most impressive specifications. It may be the one that can be produced quickly, deployed widely, and replaced when necessary. The future of air defense won't depend on one weapon. It will be a layered network. Sensors detect the threat. Artificial intelligence helps build the picture. Electronic warfare disrupts some targets. Directed energy weapons may handle others. And interceptors provide another layer when nothing else is enough. The real revolution here isn't necessarily a faster missile. It's the possibility of changing the economics of defense. If America can build effective interceptors at dramatically lower cost, it could change how commanders think about missile magazines, production, and mass attacks. For decades, the question was, can you build a missile capable of stopping the threat? The next question may be harder. Can you build enough of them? Because the next missile defense revolution may be measured not in Mach numbers, but in dollars. Pause. Because in the next generation of warfare, quantity may become a form of technology. The $750,000 interceptor is still a program under development. Its promise has to survive testing, engineering, and the brutal economics of mass production. But if the concept works, the future of missile defense could look very different. Not simply faster, cheaper, scalable, and built in numbers. This is war tech. If you want to see how the next generation of weapons is being engineered, subscribe to War Tech and watch our next documentary, because the missile race is only getting faster.